Okay, good morning or afternoon. I would just like to go through quickly a couple of these problems to give you an example of what we need to do in order to solve equations by factoring. So I'm looking at problem number 14 from 18.1, which is one of the assigned problems for this section. And so we want to solve x squared plus 13x equals a negative 40. So step number one is going to be to get this equation to have a value of 0. So in other words, what we need to do first is add 40 to both sides. I'm just going to rewrite the problem here and leave a little space here, because what I want to do, like I just said, is add 40 to both sides. So this right side of this equation will have a value of 0, and then I can add the 40 there next to the 13x on the other side. So that's going to give me an equation of x squared plus 13x plus 40 equals 0. Now then, what we want to do from here is use this x method of factoring that I went over in the video from Monday. And so when we have a situation where we have this trinomial, okay, a quadratic equation where, you got your x squared there, and this leading coefficient is 1. In other words, there's not a coefficient in front of x squared, meaning that value would be a 1, then we can use this x method of factoring. And what we need to do is we need to find two numbers that multiply to equal this last number of 40. And those same two numbers will also need to be able to add to the 13. And so what we want to do is we want to start by saying, well, what numbers multiply to equal 40? Well, you got 4 and 10, of course, is 40. 2 and 20, right? 2 times 20 is also 40. And we got 8 times 5. And there's also the combination of 40 and 1. But again, what we're looking for is the combination that also adds to the 13. So what would that combination be? Well, that combination would be the 8 times the 5. So that tells us that I'd put an 8 and a 5 there just to remember that those are the two numbers on the sides of the x. And then I go ahead and I factor. Okay? So in other words, I put this into two parentheses. Where it's still equal to 0. And I say, okay, in order to get the x squared, I would need to put an x first in each parenthesis, so when they multiply together, they will equal the x squared. After each x, that's what the 8 and the 5 tells me I need to have. So I need next to one of the x's a plus 8, and next to the other a plus 5. It doesn't really matter which one goes first, but we need an 8 and 1, a plus 8 and 1, and a plus 5 in the other. So from here, what we're going to use is we're going to use the zero product property that says if x plus 8 times x plus 5 is equal to 0, then either x plus 8 must equal 0 or x plus 5 must equal 0. And then we can solve each one of these for x. And so I get either a value for x of negative 8 or x can have a value of 5. And if x takes on either one of those values, then that will solve, excuse me, the original equation of x squared plus 13x equals negative 40. Okay? Let's look at one from 18.2 as well. Okay, and so this is problem number 14, which is one of the assigned problems as well. So when my first step is the same as it was for the previous problem, where I want to make one of the sides equal to 0. I want to do this in such a way that the x squared term is going to have a positive value. So in other words, I don't want to subtract 34x and add 28x and move that to the left side. I want to bring the negative 12x to the right side, so that way the left side will have a value of 0 and the x squared term will be positive. So we're going to add 12x squared to both sides. So step one is going to be to get the equation equal to 0 by adding 12x squared to both sides. So we want to add 12x squared to both sides. Okay, so we would get 12x squared plus 34x minus 28 equals 0. Okay, so at this point what we want to do is we want to look at these three terms and we want to ask, is there anything that we could divide each one by? And so we got 12, 34, and 28. Well, the greatest common factor, the number that will divide into all three of those, the largest one, is a 2. So the next step is going to be to factor that 2 out. And so what we want to do is divide each one of these terms by 2. The 2 that we're factoring out goes, as you can see, on the outside of this parenthesis. And we would have 6x squared plus 17x minus 14 equals 0. From here, what we're going to do is do basically a guess and check method in order to factor the trinomial that we have in this parentheses. So what we want to do is make sure that the number we put first in each parenthesis will multiply to equal 6x squared. So we can do a 3x here and a 2x here. Then we'll need to put two numbers last in each parenthesis, so when they are multiplied, we would get a negative 14, which would be a negative 7 and a positive 2. Okay? So then from here, what we want to do is see if, excuse me, our two terms that are furthest away and our two terms that are closest together will multiply and equal then combine to equal a 17x. Well, I can see that I got 6x when I multiply the two furthest away and a negative 14x when I look at the two closest together. Well, those two will not combine to equal 17x. So that tells me that this is not the correct way to factor it. And what I want to change first is I just want to switch the 2 and the 7 around and see if that will work. Okay, so I'm going to put the 2 now on this side and the 7 on the next to the 2x over here, negative 7. And I want to remultiply. So now I'm getting negative 21x when I multiply the two that are furthest away, often referred to as the outer terms, and 4x on the inner terms. When I combine those two, I would get negative 17x. Well, I'm actually needing a positive 17x, not a negative 17x. But that's okay, because when you have the right number, but it's just got the wrong sign, then all we need to do to fix that issue is switch the order of the signs. So make this a positive 7, make that the negative 2, and then when we multiply again, now I'm going to multiply a 3x times a positive 7 and get a positive 21x, and negative 2 times 2x will be a negative 4x. And so then those two will be able to be combined to equal the positive 17x that we needed that middle term to add to. Okay, so from here, what we want to do is we want to, again, use the zero product property, where I say if 2 times 3x minus 2 times 2x plus 7 is equal to 0, then something that I'm multiplying by has to equal 0. Now then the 2, there's no way to make that a 0 because that's a constant. It's not going to change based on what the value of a variable is. So from here, what I want to do is I want us to say, well, 3x minus 2 could equal a 0, or the 2x plus 7 could equal a 0, and then solve each of these equations for x. So I'm adding 2 to both sides to the first equation, and then we will divide both sides by 3, and x would equal 2/3. I subtract 7 from both sides, and I get 2x equals negative 7. I divide both sides by 2, and x equals a negative 7/2. So that would then be my two solutions there. And so again, that means that if x would have a value of 2/3, it would solve the original equation, or if x was to have a value of negative 7/2, that would also solve the equation. So that's how we would solve equations using the factoring method. Okay, so make sure you've checked the calendar and you know what problems to do, and these assignments are due tomorrow. Good luck, and if you have any questions, I will be available till 8:20 tomorrow to go over any of these problems. Thank you very much. and have a good day.